Hello everybody and welcome back to the 2000 Cayley paper. We're on to question number 22. So, an ant walks inside an 18 centimeter by 150 centimeter rectangle. The ant's path follows straight lines, which always make angles of 45 degrees to the sides of the rectangle. The ant starts from a point X on one of the shorter sides, okay, so the 18 centimeter sides. The first time the ant reaches the opposite side, so the other short side, it arrives at the midpoint. What is the distance in centimeters from X to the nearest corner of the rectangle? So it'll be some number less than 18, and our possibilities are 3, 4, 6, 8, and 9. All right. So, yeah, because it's either on one side, one half, or the other, so it's got to be at most 9. All right, so let's draw our picture, I guess. We're going to have a very, very big box and then a very, very long side, and then okay, so we'll say this is 150 centimeters, and then we have 18 over here. And the ant starts at some point, I don't know, X. So what does he do? Let's use the dark blue. He walks, and he makes an angle of 45 degrees here. Now, since we have a right angle here, we're going to have another 45 degrees. So whatever distance X is to this corner, it'll be the same amount. And then he makes another 45 degrees. He bounces up to this side, and then he makes another 45 degrees here and here, and comes down over here. And then he keeps going on, 45 degrees again. And this keeps going, and eventually he winds up at the midpoint over here, so a height of 9, and say he does this. So 45 is all around. Okay, and we're asked to figure out, well, how far X is from a corner. Now maybe it just so happens that X is actually up here, and so it's going to be closer to this corner. That doesn't particularly matter. It concerns me right now. What we do know is that we have a distance of 9 from either side, because we're told the ant hits this other side the very first time at the midpoint. And now with both of these angles being 45, we know that this distance here is also got to be 9. And then if we look, we have a bunch of triangles here, and we can split them up. And so we have a bunch of right angle triangles with 45 degree angles. And the nice thing about these is, just as we used over here, if we have a right angle and 45 and 45, well, that means that these right angle triangles are isosceles. So however high you go up, that's how far you go over. Okay, so in this case, distance of 9 is the height. That means we went over 9 by the time the ant reached this side. So we're sort of working backwards from right to left, and we're going to figure out what X is by working backwards. Now, this right angle triangle here has a height of 18, which means that he must have gone 18 over, because however high you go, that's how far you go over. And same with this triangle. And then same with this triangle. And this triangle. And this triangle. And then we have some distance here, which will be less than 18. I don't know, we'll call it, so we already have an X being used, we'll call it Y. And so this distance here, Y, well, that's how high up he is. So Y could be something like 7, in which case the distance between X and the nearest corner is 7. Or Y could be something like 11, in which case it's up higher, and the distance is going to be 7 there. Because 18 minus 11 is 7. All right. So we have a total length of 150. We travel a distance of 9, and then we travel a whole bunch of 18s. I have no idea how many 18s. We've already used an X and a Y. Let's call it Z. And I know Y is going to be less than or equal to 18. It has to be. Otherwise, it would be part of another one of these triangles, and Y would be more of that bounce. Okay. So, to figure out what Y is, we sort of need to figure out the remainder when we do... So 150 minus 9 is 141. So Y is the remainder of 141 when we divide by 18. We want to get as many 18s as possible. Y is less than 18, so it's going to be the remainder. So 141 divided by 18, that's 7.833 whatever. So 7 copies of 18 will go into it. So 126, so 141 minus 126, we should get that Y is 15. So X is actually up pretty high. And we have a total length of 18, so we're going to have a very small length here of 3. So 3 centimeters is the distance, and I think that was one of our options. What is the distance in centimeters from X to the nearest corner? It's going to be 3. Do we know if it's the top corner or the bottom corner? Well, we don't, but we do know the distance of 3. The reason we don't know is because we don't know exactly how many of these triangles. I mean, we do know how many triangles, but I'm not going to figure it out. So that's A is our final answer. Oh, what do you know? A was the answer to the last one, too. Pretty cool. So we'll flip our page in anticipation of the next question, and we will take a look at that question. The other question 22, because apparently there's a typo either in this file or maybe there was a typo in the actual contest. And that was probably very confusing for people bubbling who didn't have a proctor to explain this. But yeah, that was question 22, and we'll see question 23 in the next video. So thanks for watching, and I'll see you guys next time.